right, looking at target 4.8, our master learning objective, I can use a two-way frequency table to determine if two events are independent or dependent. So, a two-way frequency table, we looked at frequency tables already. A two-way frequency table just compares two variables. So like in this table down here, right, it's what grade they're in and what gender they are, right? Boys versus girls, and then in what grade. Okay, so it's a two-way frequency table which compares the two variables. Okay. So we can, just like before, we can find probabilities from a two-way frequency table. Okay. If I want to find the probability of a boy, I have to look at my total number of boys. Okay, so if I look at just this is specifically the ones that are boys and in 6th grade. I don't care what grade they're in. I need to do the boys that are in 6th grade, the boys that are in 7th grade, and the boys that are in 8th grade. So the total number of boys is 23 out of 50. Okay, not too bad there. If I want them to be in 6th or 7th grade, well, this is exclusive. So I'm going to add up my 6th graders. Again, the total number of 6th graders is 15. And my total number of 7th graders is 13. Both of these are out of 50. Which equals 28 out of 50, which equals 14 out of 25. So that, for this being exclusive, right, it's the same formula. I'm actually going to do part D before I do part C. Part D, boy and 7th grade. When you have a frequency table, this is the only time you don't multiply with and. Okay. I'm just going to find where because I don't know if it's independent or dependent, right? That's kind of what we looked at. I have no idea if what grade you are in and being a boy or a girl is independent or dependent, so I can't multiply. So if I want to do boy and 7th grade, I'm going to go to boys and 7th grade, where those two things meet, right, is my and probability. So this is straight from the table. So then looking at C, girl or 8th grade. This is overlapping, right? I can be a girl and be in 8th grade. On our quiz, a lot of us struggled with these overlapping ones. We completely forgot that overlapping is different from exclusive, right? So overlapping, we have to do girl plus 8th grade minus both. Okay. So the probability of being a girl, if I go to the total number of girls, is 27 out of 50. The probability of being 8th grade is 22 out of 50. And the probability of both, well, if I'm a girl and in 8th grade, I'm going to follow these to that 12. Adding up the top 27, plus 22 minus 12 is 37 out of 50. Okay, so those formulas are still the same. Looking at part E then, if I do the probability of boy and 7th grade, right, we got 3 out of 25. And if I do the probability of 7th grade and boy, here are my 7th graders and my boy, it's still the same thing. So the order for and doesn't matter. That's different if we look at F and G. All right, then, so we have probability of girl given 6th grade. So this is the same, right? We still have to do our given formula, right? And remember, the probability of B given A equals the probability of A and B. So 6 and girl divided by 6. Probability of 6. Okay. So the probability of 6 and girl, right? I have to look at my ands here. So 6 and girl is going to 8 divided by the probability of just 6. Well, 6 is 15. Sorry. So there is 8 out of 30 out of 50. Can't do anything. 8 out of 56 and girls divided by 16 out of 50 6th graders. Again, if you're typing it into your calculator, I would put those parentheses, which gives us, right, again, I'm going to put it in parentheses, so I have 8 out of 50 divided by 16 out of 50. And we get 1/2. So the probability of girl given 6th grade is 1/2. Now, if we look at the 6th grade given girl, does this change? Well, if I write out my formula, that would be the probability of A and B, right? This is B, this is A, so that's girl and 6 divided by the probability of A. And the probability of A would be the probability of girl. Well, the probability of girl and 6 hasn't changed. Right, girl and 6 is still 8 out of 50. But the probability of girl is 27. That one has changed. So my 8 out of 50, the top is the same either way, but my girl is 27 out of 50. Okay? And if I type that in, I do get 8 out of 27. Okay, so this is really to show you and can switch and it doesn't affect it. Givens, if they switch, the number changes too. So the order for givens is important, where for ands, it's not important. Okay? All right. Now, the coach is splitting the group into 2 teams. What is the probability he chooses a boy and then a girl? So this is an independent, this is a dependent, because if I'm splitting it into teams, as soon as one person's on a team, they can't be chosen again. So here, now we're doing something we have to be careful with, right? So I'm doing probability of boy and girl. This one I am going to multiply because it's a dependent event. They're not like happening at the same, it's not like one person is both. If I find the probability of a boy, well, there's 23 out of 50 boys. Then I'm going to choose a girl. Well, now there's 27 girls, but there's only 49 people because the one boy is already chosen. Okay, so this is just like what we did before. So there's 27 girls out of 49 people. So I can use a table to do a lot of these probabilities that we've done before. This is just a really large number. 621 out of 2,450. Okay. All right. Let's flip to the next page. The other thing we can do is do a probability, right? Our independence test. If it's asking, are these independent, right? We have two independence tests. I could do either one of them. Right, we have our AND test. Or we could do our probability of B should equal the probability of B. Okay. So our event A is senior. Okay, so there's 181 out of 356 seniors. The student has a part-time job. There's 166 out of 356 people who have part-time jobs. And then I want A and B, so that there's seniors and have a part-time job, right? And that's 95. So if I multiply these together, I get 181 out of 356 times 166 out of 356. And I did that. And for these, I'm going to put them as a decimal so I can kind of get an idea. That's 0.237. Same thing here. This 95 out of 356. Okay. And that's 0.267. So that's 24% versus like 27%. That's a little too far off for my liking, right? If it was like 237 and 238, right, I would say like, all right, that's close enough. They're probably independent. But this is too far off. So I would say these are dependent, okay? We should get the same thing if we do this other test. It shouldn't matter which test we do. So the probability of B given A is the probability of a senior and part-time over the probability of senior. Okay. And that has to equal the probability of part-time. Well, senior and part-time, we already know is 95 over 356 over the probability of senior is 181. Sorry, running out of room, over 356. And that has to equal our probability of part-time, which is 166. I'm just going to write it down here. So I had 95 out of 356 divided by 181 out of 356. And that's 95 out of 181. Getting that decimal, it's 0.525. And then 166 out of 356. Again, get it as a decimal, is 0.466. So again, those are not close to being the same. So I'm going to say no They are dependent. Again, I don't have to do both of these. If this was a question on the test, you'll be able to choose which one you wanted to do. Either one works. Okay. All right. Let's look at example 3. In a class of 32 students, there were 8 girls who played basketball and 5 boys who did not. Construct a two-way frequency table. So this is the same thing. We have to think of our 2 different things we have. So I'm either a boy or a girl, and I either play basketball or not. And then we want totals at the end. So, there's a class of 32 students. That's the total of everyone. 8 girls played basketball. I feel like this is not enough information. 5 boys did not. We're going to add something in really quick. We're also going to say that there's 17 girls total. Also, 17 total girls. Oh, these are not enough information, so we'll put a 17 here. Then we need to start filling in. Well, if there's 17 girls and there's 32 people total, oh, well, that means I need 15 boys to make this work out, right? Same thing here, 8 plus, well, that's going to be 9. Same thing here, well, that's going to be 10. That's going to be 18. That's going to be 14. So we can fill in our totals if you have enough information, which on a test or something you definitely will. I must have just missed a direction. So now we can use this lovely table to find our probabilities, right? So look at the probability of girl. Again, we have to use this number here. So the probability of girl is 17 out of 32. Plays basketball and boy, right? That's one person's both of those things. I'm not multiplying them together. I don't know if these things are independent. I want to go down my basketball line and down my boy line. There's 10 out of 32, which equals 5 out of 16. Plays basketball given boy, right? That's the same as a line. So I need the probability that they are boy and basketball over the probability of boy, right? That's our formula. B given A, supposed to be an A, equals A and B over A, right? Well, boy and basketball, we just found out was 10 over 32. Probability of boy is 18 out of 32. For sake of time, you can type in your calculator, but that is 5 out of 9. And finally, girl or does not play basketball, that's overlapping. So that's going to be the probability of girl plus the probability of not minus the probability of both of those things. Okay? Well, the probability that they're a girl, well, there's 17 girls total. The probability they do not play basketball, there's 14 out of 32 total. And the probability that they're a girl and not, right? There's 9 of them. And I believe then we get 22. That makes sense. Out of 32, which equals 11 out of 16. Okay, so that's just our overlapping formula. All right, our last question, is playing basketball independent of being a boy? I personally believe the probability of A and B formula is easier. So we'll use that one. The probability of A and B, basketball and boy, well again, 10 out of 32 has to equal basketball. There's 18 out of 32. Boy, 15 out of 32. So then, 10 out of 32 is 0.31 something. And then on my other side I have 18 out of 32 times 15 out of 32. 0.26. Not equal. No, it's dependent. So it's basically just a review of everything we've already done. Sorry for the long video. I'll see you guys tomorrow.